Today we're talking about the dot product. So I have this note here about an introduction to some new operators. We'll talk about what that means in just a second. We're going to start by looking at what we're supposed to be able to do once we're at the end of this. So we're going to be able to calculate the dot product, which means we're going to have to understand what that means, obviously. We're going to be able to use it to find the angle between two vectors. We're going to be able to likewise determine if vectors are orthogonal. We're going to talk about what that means. Orthogonal just means perpendicular. So that goes along with finding the angle between them. If the angle's 90 degrees, we say they are orthogonal. We're going to be able to describe what a vector projection is, as well as calculate the vector projection, which is written this way. The projection of u onto v is written like this. So we have to start with what is the dot product. Okay, it's an operator, just like addition, subtraction, multiplication, or division. These operators are done with scalars, just numbers, right? Like 5 plus 6. You could add two scalars. The dot product is an operator that you can apply to multiple vectors, okay? So if I have vector u is -1, 5, v is 3, -7, the dot product would be written this way, u dot v. Okay, it's the dot product, so we just read it as dot u dot v. And the result of the dot product of two vectors is a scalar. So we're going to have two vectors. If I do u dot v, I have a vector dot product with a vector. The result is going to be a scalar, just a number. The way this is done is you're going to multiply the x parts together, -1 times 3, and you're going to multiply the y parts together, 5 times -7, and you just add those two results together. So I have -3 minus 35, so the result of this dot product is -38. So I had two vectors to begin with. If I take the dot product of two vectors, the result is a scalar, just a number. So that's this new operator dot product. That's how it works. X times x plus y times y, that number is the result of your dot product. So when is the dot product useful? We can use the dot product to find the angle between a couple vectors. We have this formula right here. Cosine theta is u dot v over the magnitude of u times the magnitude of v. So we're going to use this formula to find the angle between the vectors u and v given here. U is 2, -5, v is -1, -3. So again, we're using the fact that cosine theta is u dot v over the magnitude of u times the magnitude of v. So we need to find out what the dot product is, and we need to find these two pieces of information. So u dot v, using the idea of a dot product, we should get 2 times -1 plus -5 times -3. So that's -2 plus 15, so that is 13. So that's u dot v. Magnitude of u is the square root of 29. And the magnitude of v is the square root of 10. So then cosine theta is 13 over the square root of 29 times the square root of 10. So then theta will be the inverse cosine of whatever this ends up being. If we type all that in, we get our angle, which is approximately 40.2 degrees. Okay, so little formula here to find the angle. We're doing this just because we're looking at an application of the dot product. We're learning this new operator with vectors. This is one application of the dot product. Very useful one. So using that idea, when are two vectors orthogonal? Orthogonal is just synonymous with perpendicular, right? So we have this formula for finding the angle between two vectors. we know that cosine theta will equal 0 if this numerator is 0, right? 0 divided by anything is 0. So if u dot v is 0, this whole thing is 0. If this whole thing is 0, then cosine theta is 0. And we know from the unit circle last semester, cosine of 90 is 0. So if this is true and this is true, then the theta has to be 90, meaning the vectors are perpendicular. So the nice part is we don't have to mess with this entire formula if we are asked to determine if they're orthogonal. All we really need is the dot product. So to check and see if the vectors 1, 5 and negative 5, negative 1 are orthogonal, we find the dot product. Negative 5 minus 5 is negative 10. Since this dot product gives us a number other than 0, we say these two are not orthogonal. Okay. Next example, determine if these two vectors are orthogonal. Same process, we want to find the dot product. When we do this, we get negative 2 plus 2, which is 0. Since the result of this dot product is 0, we say yes, these are orthogonal. So in a question like this, if I'm asking to just determine if they are orthogonal, all you need is the dot product. Because if this dot product is 0, then you know the cosine of theta is 0, and if the cosine of theta is 0, the angle is 90 degrees, which means it's perpendicular. So a few steps to the logic there. Nice part is, determine if they're orthogonal, find the dot product. If it's 0, yes, they're orthogonal. If it's literally any other number, not orthogonal. So that's one application of the dot product, is the angle between vectors. Another one is this idea of a vector projection. So first off, visualizing what a projection is. So we're going to look at this. We're going to look at the projection of u onto v. So that's how we write it. We say the projection of u and then the subscript vector v. And that's the projection of u onto v. As a picture, what that means is over here, if I look at u, if I drop down a perpendicular right here, the projection is going to be this vector right here. Okay, it's kind of like if the sun is directly overhead, like the javelin problem from our quiz. If the sun is directly overhead, it's going to create this shadow at a 90-degree angle. The projection is kind of that shadow. So a projection is you go from the end of vector u, since we're taking the projection of u onto v, end of vector u, perpendicular to vector v, and it's just that section of vector v is the projection of u onto v. So it's, like I said, it's kind of like the shadow of vector u on vector v. The formula for this, a little bit more complicated than the formula for the angle between two vectors, but it's u dot v over magnitude of v squared all times v. So this should be a number. The dot product gives us a number. Magnitude squared gives us a number. Vector v is a vector. So we're going to end up with some fraction times vector v. So let's take these two vectors here. U is 2, 5. V is 6, negative 1. What is the projection of u onto v? So we need to start by getting the dot product. U dot v in this case is 12 minus 5, so 7. Then we need the magnitude of v squared, which should be 37. If we find the magnitude of v, it's the square root of 36 plus 1, so the square root of 37. If you square that, we get just 37. And then we're multiplying by vector v, so 6, negative 1. So then if we're going to write this just as a vector without that multiple in front, this is going to be 42 37ths and negative 7 37ths. That is the projection of u onto v for these two vectors right here, right? So to be clear, those are not the vectors I was drawing in the graph at the right. Okay? But that's how you find it. And that's the, like I said over here, that would be like the shadow of this vector on this one. So just another application of dot product. So at this point, you should feel comfortable calculating the dot product of two vectors, calculating the angle between two vectors, determining if two vectors are orthogonal. You should be able to describe to me just in general, and to each other in general, what a vector projection is, as well as being able to calculate the actual vector projection. So those are the things you should be able to do, and we will be working on the homework in class like usual.